Welcome to my talk, The Tech Tales, How Data DX Enables Business Success. And one quick thing up front, this is not going to be your typical tech talk. Instead, today I'm going to tell you a story of two startups, a story of important technology decisions, a story of pain, frustration, joy, and productivity. So lean back and let me take you into the magical world of data DX. But before that, my name is Nikolas Burk. I work as a developer advocate at Prisma, and we are building database tools for engineers like you to make your lives easier when you're building data-driven applications. And these two fellas here are my cats, and these troublemakers are also the reason why I'm sitting down here and not standing up and walking around freely on stage as I usually would, because I injured my knee last week while playing with them. And in general, I'm a huge fan of cats, which will also manifest in a different capacity throughout the talk, but I don't want to spoil too much yet, so just stay tuned. So, okay, it doesn't work. I was whistling Star Wars, but I don't think it gets through. Once upon a time in this universe, far, far away, there was a market opportunity. A social network for, you guessed it, cats. I'm choosing the social networking app as an example application for my talk because I think it illustrates quite well a lot of the common engineering challenges that a lot of us are dealing with on a daily basis, such as basic CRUD operations, real-time functionality, and scaling your application to a larger, potentially even a global audience. And in this race for disrupting the cat industry, we have two contenders, Feline Fumble and Perfect Pause. And in the first act of the story, the two startups, they set out to build the MVP, a pretty basic social networking app where users can create profiles, they can connect with other users, they can post status updates, these kinds of things that you would expect from a social media application. And they set out to build the application. They start with a 3-tier architecture using Postgres, Express.js, and React.js on the front end. And the first really critical tech decision that the two teams are facing is whether they should introduce an abstraction for their database or not. Should they just go with plain SQL or introduce a high-level abstraction like an ORM? And let's see what choices the two teams make. So Feline Fumble, they decide to go with plain SQL because they want to have full control over all the database queries that are sent to the database and all database interactions in general. And this is what it looks like when they send in queries to the database in their application. Perfect Pause, on the other hand, they value the productivity that's promised by a high-level abstraction, and they decide to go with Prisma ORM, which enables them to model their data in an intuitive way, in a human-readable way. It provides auto-generated migrations from the Prisma schema, and also allows people to query the database in a type-safe and intuitive way. And this is what it looks like when you send queries with Prisma Client. So how did this work out for them? Well, when Feline Fumble started, one of their database migrations failed right at the start and left the database in an inconsistent state, and they spent quite a while debugging that. Then their senior engineer became sick, and she was the only one who really had experience writing SQL on the team. So now that she was gone, the junior developers had to take over, and it took them a lot longer to figure out the right SQL. And overall, they lost a lot of time due to the manual work related to manual schema migrations, manual queries, no type safety, slow iteration speed, no productivity overall. Perfect Pause, on the other hand, they were able to make fewer mistakes thanks to the type safety provided by Prisma Client. Also, the database abstraction allowed the junior developers to be productive and really contribute to the features that were being built. And the auto-generated migrations enabled the team to iterate fast on the features that they were building. So after a while, both teams ended up getting their MVP out and started to see more users. More users, more problems, more users were trickling in, and even some cat celebrities discovered the app that started to cause huge spikes in traffic for the application. And the traffic spikes were that notable that it really impacted the financial planning, especially in terms of the database cost and the load that was happening on the database layer. So the CTOs of both startups sat down and tried to figure out a solution for that situation. And the solution that both came up with was that they wanted to introduce a caching layer for their database. So the teams go to work. Feline Fumble, they introduced Redis as the database cache on top of their database. So they go and set up and configure Redis, they integrate it with their application, they modify the query logic, and they implement and configure expiration policies for the cache. If we look at all of these steps, we actually can realize that each of these steps comes with a lot of tiny decisions that need to be made, but also quite a bit of manual work every time. So when you set up and configure Redis, you need to decide, do you want to have a manual installation or do you want to use a managed service? You need to take care of things like authentication and configure options, memory limit, persistence options, IP whitelisting, a lot of small stuff. Then you need to install the Redis client in your application, establish the connection to Redis, modify the query logic to implement the cache, check if the cache already has the query result of a particular query, then query the database if it was a cache miss, define cache keys, and store the data in the cache. When you talk about expiration policies, you need to think about time to live and stale while we validate option, and of course, take care of cache invalidation as well. So a lot of stuff, a lot of work. Let's see what Perfect Pause decided. They decided to go with Prisma Accelerate, which is a global database cache that integrates seamlessly with Prisma ORM and offers fine-grained cache control on a per-query level. And the integration process for them looked like this. They first connected Accelerate to their database, then they installed Accelerate in their application, and then they started caching queries with the Accelerate API, where you can configure the cache strategy for every individual query that you're sending to the database in terms of style while we validate and time to live. How did this work out for both teams? Feline Fumble took a lot of time to set up and manage and configure Redis, and they also started to see some user issues coming in. A lot of users reported that they were only able to see outdated posts. So the team went in to debug, they found that there were issues with their cache and validation logic, took a lot of time to fix, ultimately not a lot of time to build any other features. Perfect Pause, on the other hand, they were able to manage the increased load while staying in their financial budget. They also were able to build additional features, so their users can now create groups according to their interests or organize events through their platform. And finally, they really were able to offer a good user experience with reduced latency thanks to the cache and thanks to the fine-grained cache control that Accelerate offers. Hack number 3, real-time features and keeping the users engaged on the site. So one recurring theme in the user feedback that both teams received was that users found it annoying that they always had to hit refresh in their browser in order to see new content. When a new message or a new friend request arrived, they always only saw that after refreshing the page. And the two startups, both teams realized they can improve the user experience and they can make the entire site a lot more fun, interesting, and engaging to use if things are happening in real time while users are using the site. So they set out to build real-time functionality into the application. Feline Fumble introduces Apache Kafka as a message bus. And the way how they do it is they set up and configure Kafka, integrate it with the application, and then adjust the application code to ensure data consistency. And again, a lot of tiny things, a lot of decisions, configuring of brokers, Zookeeper. I don't know who of you has worked with Kafka, but it's not a pleasure to do that. Installing the client, defining Kafka topics, producing consuming events, and then data consistency in that situation also is very tricky. You need to deal with topic reliability, failure handling, acknowledgement, and retry mechanisms are just a few of the things that you need to consider. What did Perfect Pause do? They chose to use Prisma Pulse. Prisma Pulse is a service that allows you to receive updates from your database directly when they happen with Prisma Client. And the way how they went about integrating that was by connecting Prisma Pulse to their database, installing it in their application, and then started streaming database change events, which looks a little bit like this. So for every model that they have defined in their Prisma schema, they can now invoke this stream method here, then whenever an event happens in the underlying database table, in this case on the message table, the database is going to fire an event to Pulse, which will distribute it to the subscribers. And at this point, I want to take a quick step back because I really want you to understand the architectural difference between these two approaches. So what Feline Fumble did is they chose this approach that's called dual writes, where the application server needs to do two things at the same time. It needs to update the database, and it also needs to send a message into Kafka. Now, whoever of you has worked in such an environment and with such a dual write pattern, you'll probably also be familiar with the so-called dual write problem. The dual write problem occurs when one of these updates fails. So in our social media application, for example, imagine a user receives a new message and they do receive the notification for the new message, and then they want to open it, but they can't read it. No message is there. Well, one of the two updates went wrong. The update to Kafka to deliver the notification, that worked, but apparently the API server wasn't successful in storing the data in the database, so this is called the dual write problem. And it may sound easy to just say, well, I'll just do a retry or maybe introduce some transactional guarantees on the application layer to work around this, but the dual write problem is actually a fairly well-recognized problem in the domain of distributed systems, and it's really, really tricky to solve in the sense of capturing all the edge cases while retaining the real-time characteristics that you set out to provide in the first place. So it's very tricky and very difficult. The way how Prisma Pulse solves this problem is by using the idea of unidirectional data flow and implementing the so-called change data capture pattern. In this pattern, all events are always triggered by the database. So the database is the source of truth. Whenever a write operation happens in the database, it's going to push the event into Prisma Pulse that is running the message queue for you, and from there the events are going to be distributed to all relevant subscribers. So we very elegantly circumvent the problem of, or sidestep the problem of dual writes. So again, how did these technology choices work out for the two teams? Feline Fumble spent a lot of time setting up and managing Kafka. They saw some UX issues coming in where messages did get lost. That scenario that I just described happened for Feline Fumble as well, and lots of time was spent debugging, very little time was spent building new features. Perfect Pause, on the other hand, their users did receive the updates in real time, and the great UX led to a high engagement on the site, and Perfect Pause was able to grow their social network to a global audience. Doom finals. All right, so despite all the struggles, even Feline Fumble also managed to grow their audience to a global one. And now, in the final act of the story, both teams want to still provide a snappy and fast user experience for their global audience, for the users that are distributed across the globe. So they both decide to move parts of their API layer into edge functions. For those of you who haven't heard of edge functions, like Cloudflare Workers or Version Edge functions, you can kind of think of edge functions in a similar way as traditional serverless functions like AWS Lambda, in the sense that both are a way or both provide ephemeral compute. However, there are some notable differences between edge functions and traditional serverless functions. For example, edge functions by default are globally distributed. That means when one of your users, you're using edge functions, and one of your users is hitting your site in the browser, the HTTP request is going to hit the data center that is closest to that user. Also, edge functions typically don't suffer from cold starts because they don't use the standard Node.js runtime, but run in other runtimes like V8 isolates. these other runtimes also are more constrained. So that's kind of the drawback of edge functions, that you run in a more limited environment, you don't have access to all the standard Node.js APIs, and you're also more constrained in terms of resources, CPU, RAM, these kinds of things. So how did the move to the edge work for both companies? Feline Fumble actually initially saw a lot of their requests failing. And the reason was, as they found out, that the functions exhausted the database connection limit. If you think about it, when you use ephemeral compute, like edge functions or serverless functions, to access a database, every function needs to open its own database connection. Now, when you have a traffic spike and you have hundreds or even thousands of connections happening at the same time, at some point, your database will not be able to provide any new connection slots for new database connections, and the database connection limit is exhausted, the requests are going to fail. And that's exactly what happened to Feline Fumble here. Also, their move to the edge actually wasn't that fruitful, because while the HTTP requests were being served closer to the users, their data was still residing in a single location in the Postgres database and in the Redis cache. So the HTTP requests could be served faster, but the database query still needed to travel a long way to that original location. So ultimately, in terms of latency, the users actually didn't gain that much. Ultimately, Feline Fumble ran out of money, and their engineers are now looking for new jobs. Perfect Pause had a seamless transition to edge functions thanks to Accelerate, because Accelerate actually not only offers a global cache, but also an external connection pool that sits on top of that database. And that connection pool is able to remedy these issues that you have when exhausting your connection limit.
Yeah.
And also, this global database cache that Accelerate provides, it actually caches data at the edge, which is super handy when you're using edge functions, because an edge function can essentially grab the data from the same data center that it has been invoked in. So it's really close, the compute and the data living side by side. What did we learn from this? What is the moral of this story? I think an excellent data DX, first and foremost, is about making the right technology decisions. We saw over and over again how Feline Fumble struggled in this story because they chose technologies that were very time-consuming and very difficult to maintain and operate. Perfect Pause, on the other hand, they made smart decisions considering their context as a fast-moving startup where they really valued productivity, and that allowed them to outpace Feline Fumble and ultimately win the race between the two. And then we also saw by practical example how the great data DX allowed Perfect Pause to increase their productivity and ship fast, along the way reduce their spending and save resources, and probably most importantly, keep their developers and users happy. If you're curious about Data DX and you want to learn more, you can go to the Data DX manifesto that you find on datadx.io. And that is all I have for you today. Thank you so much.
Yeah.